All right, so you guys are used to finding answers to quadratics. Now, I'm going to really throw a curveball at you. I hope you watch the pre-lesson because this is going to be kind of strange if you don't watch the pre-lesson. But all you're going to do is go through this checklist right here. Now, as you can see, it says the discriminant. The discriminant is this portion of the quadratic formula, which is negative b plus or minus the square root of b squared minus 4ac all over 2a. Now, you got some rules here, and they're true, but this is just not necessarily how I teach it. I have my students just go ahead and plug it into the quadratic formula because it's good practice, and then go through the checklist. So, with that being said, one of the things we have to do is set it equal to 0, identify what A, B, and C are, and then plug them in, and then determine and go to your checklist to see which, if it's real or imaginary, equal or not equal, rational or irrational. But you got to watch the pre-lesson to make sense of all of this, because it's quite confusing if you don't take a second listen to the pre-lesson. So let's go. There's an invisible 1 there, so A is 1, B is 6, C is negative 2. So negative b plus or minus the square root of b squared minus 4 times a times c all over 2a. See, we don't really need this piece, and we don't really need this piece for this, because really what we're going to do is we're going to concentrate on this, which is our discriminant. Now, this doesn't bring the square root along with it. I think we should. You'll see why in a minute. So 36 plus 8 is the square root of 44. So let's go through our checklist. Number 1, is this number real or imaginary? Well, because there's no negative, it's real. Number 2, are the answers going to be equal or not equal? Well, as you can see, you got negative 6 plus the square root of 44 over 2, and you have negative 6 minus the square root of 44 over 2. So those are two answers that are not equal. And then 3, rational or irrational. So, as you can see, irrational numbers, and you listen to my pre-lesson, if you type this in your calculator, you're going to get some strange decimal. So that makes it irrational. The only time you're going to have a rational one is if you have a perfect square root. All right, let's move on to example 2. My A is 1, my B is 1, my C is negative 6. I'll label it, plug it in, negative b plus or minus the square root of b squared minus 4ac all over 2a, which would just be 2. Again, we're just going to concentrate on this portion and look at it. Wouldn't that be the square root of 1 plus 24, which is the square root of 25? And so now we're going to concentrate on this and go through our checklist. Is this a real or imaginary? It's real. Number 2, equal or not equal? Well, remember, we're going to have negative 1 plus the square root of 25, which is just 5, and negative 1 minus the square root of 25. Those are two totally different things, so they are not equal. And you see how I wrote not equal, and then I wrote equal in a symbolic, unequal with a symbolic. I don't care what you use. 3, is it going to be rational or irrational? Well, because this is a perfect square root, we're going to say that this is rational. And that's what you're going to be doing for today. All right, let's take a look at this one. Now, some of you might look at this and go, hey, wait a minute. I can factor this. X minus 3, X minus 3. You see, this is where looking to factor things might help. So I get X equals 3, or from this one, I get X equals 3. You see, this is a perfect square trinomial, and they're going to give you the same answer twice. So if we go through our checklist right now about our answer, are these answers real or imaginary? They're real. Equal or not equal? These two answers are the same, so we're going to say they're equal. Rational or irrational? These are rational numbers because they're nice, neat, little whole numbers. And that's one way of doing it. But I bet most of you would just stick with the program and watch this now. Negative b plus or minus the square root of b squared minus 4. See if I can pack this in here. 1, 9. Okay. All over 2a, which is just 2. Now I want you to take a good look at this. This is just 36 minus 36. So this is really the square root of 0. So when you get the square root of 0, here are the rules. Is that real or imaginary? Well, that's real. This is where it gets confusing if you go this route. But as you can see, the answers are equal. But if I actually finish this, I would get 6 plus or minus 0 all over 2. And this would just disappear. And I'd get 6 over 2, and I would get 3. And I'd think, well, I only got one answer. Well, that's the mystery of the quadratic formula. If you actually have two equal answers, the quadratic formula will only spit out one. And when that happens, you say, aha, I know that this is actually giving me two answers. So these are equal, but that's a confusing thing if you don't notice that it's factorable. And then, of course, are our answers rational or irrational? Those are rational. That one's a weird one. This one, here's my A, here's my B, here's my C. So negative b is 6, plus or minus the square root of b squared, which is 36, minus 4, times a, times c, all over 2a, which is just 2. Again, we're mainly concentrating on this. But the rest of the formula kind of helps us think, especially the plus or minus, in determining whether the answers are equal or not equal. But let's go on to here. So we get 6 plus or minus the square root. Look at 36 minus 40 is negative 4 all over 2. Now you don't need to solve it, because from here we can take a look and talk about it. As you can see, the first step, real or imaginary. This is imaginary. Now, if you guys were listening to my pre-lesson, as soon as you notice it's imaginary, all you say is it's imaginary conjugates. Now, where does that word conjugate come from? The plus or minus. Remember, x plus 2 and x minus 2, you've got a plus and a minus. That's where the word conjugate comes from, and that's just buried in the quadratic formula. So as soon as it's imaginary, just like a robot, just say imaginary conjugates and you're done. You don't have to talk about anything else. Because as soon as you say conjugates, you're saying they're not equal, and these don't really fit into rational or irrational because they're imaginary numbers. So you're done. All right. Again, you've heard me say this before. We're not big fans of fractions. Some students would multiply this by 3/7. That would clean this up, but it would cause a disaster here and a disaster here. So what we're going to do is just multiply this by 3. Boom, boom, boom. So we get 3d squared plus, this 3 would cancel with this 3. So you'd get 7d equals 6. 3 times 2, 6. Subtract 6 from both sides. Remember, we got to set this equal to 0. Identify our parts. There's A, there's B, there's C. So negative b plus or minus the square root of b squared minus 4ac all over 2a. And this 2a stuff really, it doesn't make any sense to keep doing this, but I just do out of habit. So what does this turn into? Well, this is 12 times 6, which is 72. 72 plus 49 is 121. So we get the square root of 121. Now we look at this, because this is really telling us the story. But don't forget about this. This tells us the story too. So go through our checklist. Is that real or imaginary? It's real. Why? Because there's no negative in there. Are these answers going to be equal or not equal? Well, again, this is where the plus or minus helps us. Negative 7 plus the square root of 121 over 6 is one answer. Negative 7 minus the square root of 121 over 6 is another answer. So these are not equal. The only time you're going to get equal is if that's the square root of 0, and that didn't happen. And then is this rational or irrational? Because the square root of 121 is 11, it's a perfect square root, we say it's rational, because we don't get a weird number. That's really what this means. You get a nice whole number, 11. Last one. On this one, I'm going to encourage you to do it differently. I'm going to encourage you just to go like this. Divide by 3, divide by 3. Use a technique that we've learned earlier. That's where math kind of builds on math. And remember, the goal is not necessarily to find the answer, it's to talk about your answers. Like, what kind of answers are you getting? And see, just by dividing by 3, I get this, and I should say, wait a minute, I remember this from completing the square. Bada boom, bada bing, do the right thing. So I get x minus 1 equals plus or minus 1. Whoops, well, I'll leave it, square root of 1. And then I go add 1, so I get x is 1 plus or minus the square root of 1. I'm going to leave it like that on purpose because this is really what we need to talk about. It's real. It's the square root of 1. And if you think about it, it is 1. So 1 plus 1 is 0. 1 plus 1 is 2. 1 minus 1 is 0. Those are two different answers we're going to get. So they would be not equal answers. But because this is a perfect square root, our answers would be rational. Remember I just told you our answers would be 2 or 0? These are nice little neat numbers, therefore they're rational. Okay? Now if you got the square root of like 7, irrational. Square root of 5, irrational. Square root of 4, rational. See that? So these weird square roots are irrational. These nice square roots are rational. Keep that in mind. And that sums it up, guys. Good luck on your homework.